In the last section, we looked at confidence intervals, but we focused on the idea that our standard deviation from the population was either known or we had a large sample size. We used 30 as our number there. What if we have a sample size here that's less than 30, so my n value is less than 30, and my standard deviation is coming from a sample and not the population? Well, as we know with standard deviation, it's not resistant to outliers. So if I'm looking at a small sample, the standard deviation from the sample could be very affected by one or two extreme values. Well, now we need to focus on the idea of a t-distribution. We've been focusing all year so far on a z-distribution. There's a lot of similarities between these two. The first, when we talk about similarities, is that they're both bell-shaped. They're both symmetric around the mean. The mean, the median, and the mode are all equal to 0 and located in the center. And the curve never touches the x-axis. If we think about our z-distribution, or our standard normal curve, it looks typically like that. Our t-distribution is going to look very similar. The only difference is there's going to be a lot more room on the sides and less in the middle. And we've increased the possibility that something's going to fall out here. And the reason for that is because we're only looking at a standard deviation from the sample. And since our standard deviation most likely will be a little bit more off, we have to account for the fact that there's a lot more variability in this case. So what are some of the differences? Well, first of all, the variance is now greater than 1. We based everything on the standard normal distribution, where we said everything was based on 1. We had a standard deviation of 1. That's not the case anymore. We have a family of curves. Instead of having just one curve like the standard normal curve, we have a bunch of curves. And that's going to depend on what we call degrees of freedom. And as your sample size goes up, and this is a big one, as your sample size increases, the t-distribution will start to look more and more like that standard normal curve we're used to. So then what do we do to find our confidence interval? Well, the first thing we have to do is find our degrees of freedom. And degrees of freedom is simply going to be your sample size minus 1. We'll talk more about what degrees of freedom are in class, but for now, just accept the fact that if you take your sample size, whatever that happens to be, and subtract 1 from it, you're going to use that value in the chart, which is on page 13 in your packet, for my t-distribution. I will go check that out now. The formula is going to be very, very similar. It's still going to take my x-bar into account. It's still going to add and subtract. The only difference is now, instead of looking at a z, we're going to put a t in here. And instead of being my standard deviation from the population, it's going to be my standard deviation from the sample. The one thing to keep in mind is your t value will always be greater than your z value, with them coming closer and closer to each other, with t starting to approach your z-score as your n value increases, as your sample size increases. In fact, as it gets past 30, these two numbers become almost the exact same thing. So let's look at one example. In the example you have, Jack is opening an ice cream shop, and he wants to ensure that the price of a large cone is comparable to all those around him. He only surveys 15 shops. The standard deviation he gets is not from the population, it's from the sample. So in this particular case, we have to use the t-distribution. So the first thing we want to do is we're going to come up with our degrees of freedom. And our degrees of freedom in this case is going to be 14, or 15 minus 1. Now, if you go to your t-distribution chart, look at the top of it. It says one-sided and two-sided. Confidence intervals are always two-sided. So all we're focusing on right now is the idea of the two-sided. And this is a 95% confidence interval. So if you look at your chart, you're actually going to go to the 6th column in where it says 95% at the top. The left-hand margin gives you degrees of freedom. Since the degrees of freedom is 14, come down to number 14, and if you work your way across the chart, you'll find your t-distribution is equal to 2.145. Once I have this number, find the confidence interval is the exact same idea I did before. I'm going to take my mean, 3.14 or $3.14, add and subtract, in this case, my t-score, 2.145, times my standard deviation over the square root of not your degrees of freedom, but your n value. This is going to give me an interval of $3.14, give or take 33 cents, which tells me that with 95% confidence, the true value of an average ice cream cone in this particular area is somewhere between $2.81 and $3.47. So the process is very, very similar. The only difference is if you have standard deviation from a sample and a small sample size, you need to focus on that chart and deal with the t-distribution. And this will allow for more extreme values. This gives us a little wider interval.